Hi there, my name is Matt. I'm the CEO and founder of Virgo, and today I'll be giving you a quick demo of our new product, EndoML. EndoML is a platform that's designed to help any user, regardless of their background or experience with machine learning, to train their own AI models using their own data. So to get started, go ahead and navigate here to app.endoml.ai. It'll take you to this sign-in page. If you don't have an account already, click right here, and you can go ahead and create your account. Or if you've already got an account, we'll go ahead and get signed in. All right, and once you're on the home page, you should initially see just a single project. It'll be this template project here for Barrett's esophagus versus normal esophagus images. These were kindly provided by the GastroVision Open Dataset project. If you want to check that out, there should be a little hover icon here, and you can see a link to the GastroVision dataset. And what we can do within the EndoML platform is load images, annotate images, then train models, and finally make predictions on new images. So for this demo today, we're going to take a look at a polyp versus no polyp image dataset. These are images that I've uploaded from the GastroVision dataset as well. They come labeled either as not having a polyp, just being normal, colon, mucosa, or images with a polyp. So I've got most of these already loaded, but I'm going to go ahead and add the final batch of images here for demonstration. And so we'll select the right project, polyp versus no polyp. I've already created some labels for this project, either images with a polyp or no polyp images. We'll select that, and then let's go ahead and we'll drop in the last frames here. All right, so I'm going to go to the demo here, polyps versus no polyps. I'll take the no polyp images, and this is the last batch that needs uploaded. So we'll upload these 18 images. All right, and what you can see is that images that had previously been uploaded, I've already processed, and they'll have these green checkmark icons on them. But the new images are not yet processed, and we now have this purple button that says Process with EndoDyno. And EndoDyno is the AI foundation model that really powers the entire EndoML platform. EndoDyno is an AI foundation model that was trained on data from over 3.5 billion frames of endoscopy, over 130,000 unique procedure videos. And the foundation model pulls out these really powerful feature representations from a given image that make it easy to train classification models, segmentation models, etc., using relatively small labeled data sets. So what we'll go ahead and do is process the new batch of images we just uploaded. You can see this is going to take 18 credits to process. It's 1 credit per image, and we'll go ahead and kick that off. All right, so those should process relatively quickly here. And once they're processed, we'll have all of our images for the project both labeled and processed using EndoDyno. If you do need to adjust any of the labels, you can go to the Annotate tab here. And what you'll see is that each label is assigned, each image is assigned one of these labels. If you do need to create new labels, we'll say large polyp, whatever you might want to label. That will add in here as an option. We can also remove it. You can navigate this with your arrow keys. And if you need to change any of the labels or assign labels, you can use keyboard shortcuts. So if I want to switch to polyp, I'll just press the 1 key here, but I'll go ahead and go back and switch that back to a no polyp image. All right, and if we go back to our projects page, we should see all of the images have been processed. There's no purple button to do any additional processing, which means we are ready to move on to training. So for training, we're going to come over to the Train tab, and initially we'll see this nice data visualization that will show us how many images we have in each of our classes. So here the classes are polyp and no polyp. We've got 809 polyp images and then 1,447 no polyp images. Over here on the left, we can see how many total labeled images, how many images have their EndoDyno embeddings, and any models that we've already trained. We can also switch through different projects here. And when we're ready to train our first model, we go to this basic configuration tab. And I really meant it before, and I said that EndoML is meant to be a tool for anyone to come in and train their own models. If you're not familiar with anything related to machine learning, you can go ahead and just stick with all of the defaults here on these sliders. But each of these categories will have a little bit of information to help guide the user through how they may want to consider modifying their training experiments. But we're ready to train our first model. We'll call this EndoML demo polyps v1. All right, and I am going to go ahead and leave all of these settings at their default, and we'll click Start Training. Training is going to consume 1 credit per epoch. The epochs you can increase by 10 at a time, up to 100. And this will take a little bit to load up all of the images from this project. There are over 2,000 of them, and then it will kick off the training run. You'll see updates here as they're happening. All right, just about done. And once the training is complete, we'll see just a quick readout, 94.7% accuracy. We can click on the model details here, get a nice summary of the training configuration. There's sharing functionality if you want to share information about the model to X or LinkedIn. You can also download a little image that summarizes the performance of your model. And then here we'll see performance by class. In this experiment, we only have the 2 classes of polyp versus no polyp. You can have as many classes as you want, but it is important to have at least 2 classes as a minimum. But you can see here, pretty solid model performance. And now we can look at the confusion matrix, which will show us how the model predicted on this final test set. So the test set, these are images that the model doesn't get to see at any point during the training process. And then once the training is fully complete, it gets evaluated on that test set, and the results are what we see here in the confusion matrix. So across the top, this is what the model predicted, either polyp or no polyp. And then going down the vertical axis, these are the actual labels that we've assigned. So you can see only a handful of mistaken predictions here, but in general, pretty good performance. We'll see, maybe try one more experiment, 1 or 2 more experiments. We'll see what happens if we bump up the number of epochs, let's say 50 epochs. And I'm going to reduce the batch size slightly. This can take a bit longer, but also is possible to get better results. And I'm going to increase the weight decay slightly. Increasing the weight decay will help prevent the model from overfitting on its training data. Let's go ahead and kick that off. All right, so this one will take likely just a little bit longer to run through the additional epochs. Also with a slightly smaller batch size, can take a bit longer on a per epoch basis. But in general, you can see still pretty quick. Again, this is part of the value of EndoML and using a foundation model. Most of the hard machine learning work is actually done at that foundation model level when we first processed the images through EndoDyno. Once we've done that, it's relatively easy to run quick experiments so you can play with these different hyperparameters until you get to a model that you're satisfied with the performance. All right, what we can see here, it looks like the training accuracy has basically maxed out. Our validation accuracy is still fluctuating a bit, but we'll let this run all the way to fruition and see how it compares to our first model. All right, so looks like our accuracy was down slightly. We'll go ahead and look at the detailed metrics. All right, so not bad, but a little bit worse than the first version. If we look at the confusion matrix, just a few more missed predictions, but in general, pretty good. All right, from there, let's go ahead and maybe try one more experiment. So if we want to do version 3 here, I'm going to reduce the number of epochs just a bit. I'll increase the batch size back to 16. And one of the areas where EndoML and EndoDyno really shine are situations where you have less training data available. So we can actually test out the performance here. Just to go back to this train val test split, what this means is 80% of our overall data, so 1,805 images, are used to train the model. We've got 10% of the images, or 225 images, that are used for validation. And so this is kind of during the training process, the model can periodically evaluate how it generalizes to a new validation data set. And then, as we mentioned before, the test set of holdout images that the model doesn't get to see at all. So what we'll do to show the power of EndoML and EndoDyno, I'm going to reduce the size of the training data set pretty dramatically. Let's go and reduce it to, say, 30% here. And that means we're going to have 35% of the images for validation and 35% of the images available for test. So in theory, this is a much harder task to train a model on. There's many more images that it has to make predictions on. But one of the things this can do is give us a good sense of how the model will generalize to new data that it hasn't seen before. All right, so I'm going to go ahead and kick that process off. And we'll see how the results come back. All right, so as expected, the accuracy dipped just a bit. But if we go in and look at the results here, we can see overall pretty strong. On the no polyp, our recall was a little bit lower. And if we look at the confusion matrix, you can see there's many, many more images that the model is trying to predict on. So percentage-wise, making a similar number of mistakes, but you can see there's many more images that it is misclassifying. But this can be a really nice way to stress test your model, get a sense of, again, how the model will generalize to larger data sets or data that it hasn't seen before. If your test set is really small, just statistically, it can be easier to get lucky and have a model that is able to guess the test set better. That gets harder and harder as you increase the size of the test set. So I'm going to see if we can squeeze out just a little bit more performance here. We'll do version 4. I'm going to bump this up to, let's go all the way to 100 epochs. And let's see, I'll max out the weight decay and we'll reduce the batch size just a little bit. Let's see how this does. All right, so a little bit worse still. I'm going to try one more just for good measure here. So let's drop that down, reduce the batch size to 8. I'm going to take the learning rate down just a bit. And let's go ahead and see what happens with fewer batches. Fewer epochs. All right. All right, so roughly the same as the version 3 model. Let's go ahead and take a look at the details. All right, and if we want, now we can actually experiment with these models and see how they perform. All right, so to test the models out, we can use the prediction page. So go over here to predict. Now we've got all these models available to us. Remember, the version 1 and version 2 were trained using much smaller test sets, which can be a little bit easier. They also had more data available to them for the training process. And I'll go ahead and add in some images. So you can imagine if you're out there in the real world and you train a model and then you start collecting more data prospectively and you want to see how these models perform with that data, we can come in here and we will add some new data that the models have never seen before. So I've got 10 images that are labeled as no polyp and 10 images that are labeled as polyp. We'll upload each of those. We'll see what happens if we select the first version of the model. We can always go back and predict on the rest of the images also. but we should have all these images here. We're going to predict on all 20 of them. The first thing that's going to happen is each image will get processed by EndoDyno. And then once they're all processed, we will see the prediction happening, and we can go take a look at the prediction results. So completed the processing, it's running prediction. Prediction tends to happen very, very quickly. And there we go. I think all the images have now been predicted, and we can go here. All right, and if you want to look up at the top, you'll see the image name has the label that's from the actual data set. And we'll just go through and see how it performed. So we've got a polyp image, was very confidently predicted as polyp. Same here. Same here. All right, so this one's interesting. Still predicted as polyp, but not quite as confident. Here we've got one right on the border, predicted as no polyp incorrectly. Here we've got polyp, 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 and polyp. All right, so looks like accuracy-wise, I think we were 1 out of 10 incorrect, so 90% accurate. Pretty nicely in line with the predicted performance of the model. Let's take a look at the no polyp examples. So here we've got no polyp, no polyp, no polyp. Let's see if it gets any of these wrong. Cool. So it looks like on the no polyp example, it got all those right. And so I guess across the 20 samples, we missed one, 95% accuracy, pretty good. And again, nicely in line with the test results from the test holdout set. So this is just a quick example of how you can use the EndoML platform. Shown on example of classifying images as either having a polyp or not having a polyp. But really look forward to seeing how folks end up using the platform and are able to train models for really any image classification task. If you ever have questions along the way, feel free to send us a message here and we will reach right back out to you. There are some exciting features that we've got in the works that go beyond just image classification, but actually starting to do bounding boxes, do segmentation of objects, and then in the not too distant future, look forward to being able to use video directly in the platform beyond just still images. Again, thanks so much for checking this out, and if you have any questions, please feel free to reach out to us. Cheers.